Okay, this video is 2E on graphing absolute value where we have two variables, most like an x and a y. So we're talking about graphing it on an xy coordinate plane. So the objective is, can we graph the function obviously, and then also can we understand how the graphs related to the parent function and the understanding of translation and transformation. So let's kind of talk about that. Alright, so this is kind of how we do a lot of the graphs in this course, where we have a parent graph, where every absolute value graph is the same graph. It's this V-shaped form. We'll see that here in a little bit. Then we have things called transformations and translations. A translation, let's start at the bottom one here, is simply taking that parent graph and moving it. So it's the same graph, we just shift it and slide it somewhere else on the graph. Transformation is we make some sort of other modification, like do we make it bigger, do we make it smaller, do we flip it upside down, do we make a mirror image of it, things like that. So a lot of what we do is we look and say, how do we take the parent graph and we manipulate it to fit the new function. Okay, so that's what these slides work on here. Alright, so let's talk about the parent graph of absolute value. So here we have the function y is equal to f of x. I'm sorry, y is equal to the absolute value of x. So let's talk about a little bit better way we might see it as. Now we're in functional notation, we might see something that looks like this instead. Function of x is equal to the absolute value of x. So we'll put them both up there. And notice what we have here is, okay, let's just do a list table here. So let's just do x, y. If we plug in 0, you get 0, obviously. If you plug in -1, what's the absolute value of -1? 1. What's the absolute value of -2? 2. If you plug in +1, 1, 2, 2. So notice, no matter if I put in positive or negatives, it's asking how far away from 0 am I. So the output is always positive since we're talking about absolute value. So notice we have this V shape. So as we get 1 away from 0, we're 1 away from 0. If we get -1 away from 0, we're still 1 away from 0. So notice the V-shaped graph here. This V shape is the same every single time. The vertex is this bottom point, and that kind of shows you where the 0 point is. And then we have two slopes. We have a slope of 1 going up this way, 1 going this way. And all that says is the relationship between x and y. Now, what we're going to do is we're going to take this graph and we're going to shift it along the graph here. Now here's a transformation. I shouldn't even say negative translation. This should be a transformation because we're flipping the graph. So notice here it says we want the opposite of the absolute value. So if we plug in -2, the absolute value of -2 is 2. But then the opposite of that is -2. So we have y is equal to -2. So notice the graph gets flipped upside down because all the outputs are negative. So it's the exact same graph, just flipped upside down. So that's one example of a transformation. Okay, now we're talking about shifting the graph, and these are actually translations. So we have y is equal to absolute value of x. And then once we get that graph, notice we take the whole graph and we shift it up 2. If we take every value across the graph and you add 2 to it, what does happen to the graph? Let's look at the blue one. It gets moved up. Okay. So notice here, if it was down here at 0, 0, all we did was say, okay, move the whole graph up 1, up 2. Okay. The red graph, okay, everything get moved down 1. So it was, here's the parent graph. And then, if I took this point right here, move it down 1. Okay. So the whole graph gets shifted down. So the number on the outside is the vertical shift because you're affecting the output. Okay. It's the function plus an output more of 2. Now notice the negative graph here in green. So we have a negative absolute value. So that means it's flipped upside down, and then it's moved up 3. So it was flipped upside down, and then we move it up 1, 2, 3 spots. So notice that, so there's an example of 2 different types of transformations done to the graph. Okay, so now we have horizontal translations. Now, this gets a lot of people confused here because they look at this and say, okay, y is equal to x plus 2, and they see plus 2, and they say y is over at negative 2. You have to think, what number can I plug in for x that would balance this out to go back to 0? Well, negative 2 plus 2 would equal 0. So kind of a way to think about it is if it's ever inside absolute values or inside parentheses, you set it equal to 0. So a good way to set it is set x plus 2 equal to 0. If you subtract 2 from both sides, obviously, x is equal to negative 2. Okay. So you think, what value can I plug in to balance this out? Same thing here. Positive 3 minus 3 goes back to 0. So this is asking for, give me values that are furthest away from 3. Okay, and we'll see this in different examples and so forth. Notice this one here in the green, we have a negative, so it's flipped upside down, and we have x plus 4. So you take the opposite of that. So again, the number on the outside is vertical translation. The number on the inside is horizontal translation. I should say transformation, I'm sorry. Horizontal transformation, and it's, again, the opposite sign. All right, now we talk about the number on the outside. This is like the m value, like mx plus b, okay? But now the x is the input is an absolute value, not just an x. So this is saying if we input a value, we double it to get the output. So if you input 1, you take 1 times it by 2 and get 2. If you input 2, double it, you get 4. So the output is going up at a rate of 2 compared to the input. So therefore, the slope of the line changes. Notice the vertex doesn't change because we have no translations left or right or up and down. So here the slope, notice, is up 2 over 1, up 2 over 1. And again, it's, the negative slope of 2 on this side as well. Okay, mirror image. Black line is a slope of 4. So we go up 4 over 1, up 4 over 1. So the output is a slope of 4. Same thing here, negative 1/3. So if it's negative, meaning it goes upside down because we have negative output. And we have a slope of 1/3, down 1 over 3, down 1 over 3. So notice it's a downward slope. And red, very simply here, 1/2, so up 1 over 2. Now notice we have both a positive and negative slope because it's a mirror image. So you got to have both sides. So I like to think about, does it go upside down or right side up, depending on positive or negative. Okay, so this is kind of putting it all together. So again, let's talk about what we have here. So we talked about the parent graph is absolute value x. So once you see these absolute value bars, you know it's a V-shaped graph. Then we know we have to move it up or down based on the outside number. And then we have to move it left or right, opposite based on the inside number here. So notice the H and the K here, those designate the starting point. Where do we start left and right, and where do we start up and down? So we call that the vertex. So you can very easily get that from this notation. Then we have the number in front of the absolute value, the slope, okay? And the direction, does it go up or down? So that's kind of all the different transformations put into one function. So let's take a look at an example. All right, so notice here in the blue equation, we're going to have a starting point that's 3 up, a starting point that's negative 2, because we do the opposite. So my starting point is negative 2, comma 3. So I'm going to go up, over negative 2, up 3, and there's my vertex. And then we have a slope of 1 because there's no value up front here, so we just draw our V and move it over. So really what this is a parent graph here that got shifted over 2 and up 3. That's the only thing that happened here. So that's exactly what this function is saying. We have to shift the input and the output with those values there. Now, look at this one. A lot of people want to say it wasn't negative 4 to A value. It's not what comes first. The A value is 2 because that's a number being multiplied by the absolute value. What's this negative 4? That is really the vertical shift. So let me rewrite this equation. What it should look like the other one. So we have 2 times x minus 3 minus 4. Okay. All I did was take the negative 4 and put it back. The number by itself is your vertical shift. So this is meaning I'm going to go down 4 and over 3 to the right. So there's my vertex, negative 3, 4. So we go over 3, down 4. And then we have a slope of 2. So from my starting point, I have up 2 over 1, up 2 over 1, so forth. And notice it's positive, okay? So you got to be careful. You got to make sure you write the equation in some sort of form that does that, okay? All right, for this last one here, we're talking about y values that are less than, and so here we have inequality. Okay, so I'm going to use a test point and so forth. So let's first graph the point. So we have a starting point of 4, 2. So 4, 2. We got a slope of 2/3. Notice it goes upside down. All right. So let's go ahead and plug in a test point. So we're going to go, I'm going to test, I'll do it over here, 0, 0. So I'm going to test is 0 less than negative 2/3, 0 minus 4 plus 2. Okay, so let's simplify. So this is obviously 4. 4 times negative 2/3 is negative 8/3. Okay, plus 6/3. I don't get a common denominator. So 0 less than negative 2/3. Okay, I'm going to say no, because 0 is not smaller than a negative number. So then my shading region is, okay, if 0, 0 is not a test point, it's valid, I need to shade on the opposite side. So I'm going to shade on the lower half, the inside of the green. So let's go ahead and fill that in. Okay, because notice the test point was right here at 0, 0, and that's on the wrong side. Okay, so again, this is involving both inequalities and absolute value, or either shading inside the V or on the outside of the V, basically. All right, so that's kind of the basic information of absolute value. I want you to go ahead and try these right here. Just go ahead and read the statement and decide, okay, based on what you learned from this lesson, how does it change? So I do want you to do this before class. And go ahead and try a couple of these examples. These are just, exactly what's in an example. Go ahead and just sketch them out. If you don't have graph paper, no problem. Just draw an X and Y axis and sketch them out and label the points. Good enough. And we'll pick up from here in class.